Welcome back, fellow agriculture students, to this explainer on the absolute future of our fields. Today, we're jumping right into how we can take smart water management from just, a bunch of flashy tech buzzwords and turn it into our industry's most vital instrument for climate resilience and global food security. As future agronomists, you already know the stakes are incredibly high, but man, the tools we now have at our disposal, they are genuinely revolutionary. So let's dive right into this stark reality. 70%. That's a massive number, right? That is the staggering amount of global freshwater withdrawals currently consumed by agriculture. And here's the truly unsustainable part. With conventional methods, like your traditional flood irrigation, we are literally wasting up to 40 or even 50% of that water through sheer evaporation and surface runoff. I mean, it's just vanishing. When you combine that inefficiency with dropping water tables and the incredibly erratic rainfall induced by climate change, well, it becomes crystal clear that our current path simply cannot secure the global food supply. Moving on to Section 1, IoT Senses and AI Brains. I like to think of the modern farm as a living, breathing organism. The dense Internet of Things, or IoT sensor arrays, those act as the sensory organs. They're out there in the dirt just constantly gathering raw, multi-parameter data. Then you've got edge and cloud AI serving as the actual brain. The AI takes all those raw sensory inputs, processes them alongside historical crop data and satellite imagery, and then it outputs highly precise, actionable irrigation schedules. It's really just a perfect, continuous feedback loop. Grounding this in the fields we all know, let's look at exactly what these sensory organs are picking up. We aren't just going out and checking if the ground feels dry to the touch anymore. Modern soil probes measure volumetric soil moisture, temperature, electrical conductivity, and pH right down there at the root zone. Above ground, connected weather stations are pulling in real-time data on ambient humidity, solar radiation, and wind speed. Together, these sensors provide this incredible, real-time, multi-layered view of exactly what's happening in the crop's environment. It gives the AI the absolute perfect dataset to work its magic.
All right, let's jump to Section 2, from reaction to prediction.
Now, what's really fascinating about this evolution is how the tech has just leaped forward in the last few years, leading us right up to today in 2026. Historically, automated microdosing was purely reactive. You know the logic, it's simple. If soil moisture is low, turn on the pump, right? But we are rapidly moving past that into predictive AI. Today's systems are calculating real-time evotranspiration models and actually integrating live weather forecasts. This means the AI can literally cancel an automated morning irrigation event even if the soil is bone dry, because the system knows with really high certainty that it's going to rain in 3 hours anyway. That shift from reactive pumping to predictive conservation, that saves millions of gallons of water. And this micro-level intelligence builds all the way up to the macro level with something called digital twins. This is a massive 2026 trend. A digital twin is, well, exactly what it sounds like, a live virtual replica of a farm's entire hydraulic or canal irrigation network. By combining IoT data from acoustic and pressure sensors that detect, say, underground microleaks, farm managers can simulate what-if drought or flood scenarios virtually. This lets us pressure test our water infrastructure and patch up vulnerabilities in a safe digital space long before actual climate extremes hit our physical farms. Which brings us to Section 3, Climate Resilience and Yields. When we get this right, the environmental benefits are absolutely massive. By giving the crop exactly what it needs and not a drop more, we trigger this amazing chain reaction of sustainability. Step 1, we prevent soil degradation. As we all know, overwatering causes soil salinization and leaches vital nutrients deep out of the plant's reach. Smart watering stops this in its tracks. Step 2, we reduce chemical runoff. By eliminating excess water flow, we stop fertilizers and pesticides from washing into local freshwater bodies, which minimizes those devastating algal blooms and eutrophication. And step 3, we drastically lower our carbon footprint by slashing the massive electrical energy required to constantly run agricultural tube wells. Now let's take a look at Section 4, Real-World Smart Water Tech. It's really easy to look at all this as some distant future theory, but this digital overhaul is happening right now. For instance, India's very first National AI and Digital Water Summit is happening literally this week, in May 2026, driven by the Bangalore Water Supply Board to mandate digital twins and IoT monitoring. Over at the state level, the Haryana Water Atlas is actively using AI and GIS satellite data to combat rural groundwater depletion in real time. And looking at the private sector, Telecom giants like MTN Group have already moved way past experimental pilots. They are commercially selling integrated AI IoT soil intelligence systems directly to farmers. The tech has left the lab, guys. It is out there in the soil. Okay, let's cover Section 5, Hurdles to Full Adoption. Despite the incredible momentum, we have to acknowledge the very real bottlenecks stopping a global rollout, especially for our smallholder farmers. First off, we're battling the economics of connectivity. Rural fields usually completely lack 5G, making low-power wide-area networks and direct-to-orbit satellite IoT an absolute necessity. Second, there's a rather painful environmental irony we've got to solve: the massive amount of e-waste generated from millions of plastic sensors deployed to, ironically, save the environment, not to mention the high initial setup costs. And finally, the most critical hurdle of all, the skills gap. Farmers need hands-on training to actually trust these AI-driven suggestions. And that brings us to the ultimate question for all of us studying agriculture today. The hardware is getting cheaper, the AI is getting much smarter, but human-machine collaboration, what a lot of people are calling Industry 5.0, requires leaders who understand both the agronomy and the algorithms. Getting farm operators to trust the machine's suggestions really is the final frontier. So, as fellow agronomists entering this incredible new workforce, I leave you with this. Are you ready to bridge this gap, integrate these tools, and secure our future food supply? Think about how you are going to apply these exact concepts in your own future fields. Thanks so much for joining me on this explainer, and I'll catch you next time.